Okay, you guys, what questions do you have on that assignment? Let me ask you this. How many of you guys followed all right with that video lesson the other day? You guys got distracted by donuts? Okay. Who brought donuts? Oh, it was Andrew's birthday. See you, Lauren. Okay. What was that? Andrew's birthday, and you guys had donuts without me? Can't believe that. Yeah, man. I should have been here that day. All right. How many of you think you understood what you're doing on that assignment? You had no idea? Did she rewind it for you so you could get it or not? I'm not going to give the whole lesson, but I'm going to do one example problem. Yeah. You might want to put the texting away. Your phone? Okay. Yeah, right. All right, we corrected the assignment. We're going to move on to doing a problem from the last assignment. Which one do you guys want to do? 24? Does everybody like 24? On lesson 4-8. Okay, let's look at that problem right there. Okay, 24 states that cellular phones are becoming more popular. The numbers of cellular subscribers are listed below, right? You guys notice that this data is way old, 2002. Okay, so it's way behind. But now I bet you the number of cell users is a lot higher than that. Okay, so we're supposed to write a model that relates the millions of subscribers as a function of the number of years since 1990. B, according to the model, how many subscribers were there in 1996? And C, use the model to predict when there will be 200 million subscribers. Okay, so we're going to put this data in the computer. So I'm going to pause this while we put number 20 in the computer. All right, so we go to stat on your calculator. You guys know how to put the data in your calculator? Okay, so we go to stat, and we go to edit, number 1. And did you guys get how to clear the data out of your calculator? So you go up 1, you hit clear, and it clears it out. You got to hit the down key afterwards. It clears it out. So list 1 is going to be which the year. Okay, so someone read me the year. What years are there? 1990? 1995? 1999, 2000, 2001, 2002. You get that right? Okay, then my Y list, or list 2, is going to be 5 point, keep in mind in millions, right? 33.8, 55.3, 69 point 86, 109.5, 128.4, and 140.8. by the way, there is one problem like this on the test. Okay, so you need to know how to do this. Put the data, and I would make sure that you double check after you're all done putting the data in. Go back up and make sure you put them each in right, because having one data in wrong is going to throw your whole answer off. So I'm going to check up closer up here. Whoops. Well, I'm going to check backwards first. So I've got 2002 is 140.8, 2001 is 128.4, 109.5, and that is 86, and 8 is 69.2, 55.3, and 1990 is 5.3, and 1995 is 33.8. So I have my data in right. Okay, so next thing we need to do is we need to set a window. Everybody hit your window button. We need a window that is going to show this data. So, what do you think? What's a good X-min, you guys? Why 1990? The data's out away from the axes a little bit, okay, or away from the sides. Okay, what's the most we want to put in as our X max? 2000 and what? Well, the data goes up to 2002, but we're going to make a prediction into the future. Remember, it asked us to find when there's going to be 200 million subscribers. So if you're looking at that data, how fast it's going up, it might be a couple of years, it might be 7 or 8 years, right? Should we put 2008? Somewhere around in there? Okay, what should we put our X scale in? We're going from 1988 to 2008. We could actually leave it at 1, couldn't we? Because that's only 20 units, and that's what a standard window is. Okay, so put it 2 if you want as well. Okay, Y min, what's the lowest? 5.3, so we could probably go down to 5 maybe if you want to go. My Y max, what do you think that should be? We got to go at least to 200 million, so let's go to 210 million. 210. Now, if we're going all the way from 5 to 210, what should we go by on the scale? Let's see, 5s would put us, that's going to put us at like 40 of them. So should we go over 10? Okay. That would put us about every, that would put us about 20 of them. What? Yeah, but that would put us at 40, and 40 is going to be way bunched up. If we go over 10, that'll put us about every 20, right? Yeah, okay. Okay, now, before we can plot these points, we have to turn on the stat plot, right? So, second and Y equals will turn on your stat plot. I mean, it will go to your stat plot, and you got to check to make sure the first one's on. The first one. Turn it on. It's not on. I want plot to be like that. I want my X list to be whatever I put in. What'd you put X under? Did you guys all put it under L1? Anybody put it in under something different? And your Y list under L2, right? Okay, and your mark, is your mark on the first one? Okay, so let's hit graph. Oh wait, go to your Y equals. Let's clear everything out of there. And once you do that, hit graph. All right. What kind of function do you think that models? Linear? Well, if you're looking at this, if I was to draw a smooth curve, it's going like this, and then it's going like this. Well, if you notice, it's kind of curving up, and then it curves back out that way. Is that really exponential? Cubic? I think that's a good possibility. That's probably one I would use. How many of you think we should do that? Okay, let's try that one. Okay, so I'm going to erase this because it's kind of, notice it's going up fast, but then it starts slowing down and starts not going up as fast. And that could be a cubic function. Because remember, you guys, if I draw a cubic function over here, cubic function can go like that, right? I don't know, maybe, cubic function actually goes up more, right? It could even follow a quadratic, couldn't it? Should we try both of them, see which one models it best, should we think? Let's try, okay, let's try a quadratic. So everybody hit your stat button. Which one do we want to go to? Calc. So we're going to go to Calc, which is one to the right. Okay, we got the choice of number 4 linear regression, number 5 quadratic, and number 6 cubic. Which one do you want to try? It's kind of going out like that, so I'm starting to question whether it's cubic. Huh? What? What was that, Ramon? Okay, well, let's try cubic then. Okay. Cubic. And you hit enter. And there it gives us all our coefficients. Now, in the lesson, remember on this part, this is where I messed up. Because I told you to round it 3 decimal places. The problem with that is when you get really small numbers, that doesn't work very well. The more accurate way to do it is using the bars. It's just a lot of buttons to remember, but I did teach it to you about 2 months ago when we did linear regression. Let's just use the bars button right now. Okay, we're going to, instead of having to write all this down, just hit the y equals, and then this is, you always have to start at y equals because that's what it's going to paste it to. You go to bars, then where do I go? Number 5 statistics, and EQ, and number 1 regression, and it will paste it there for you, so you don't have to do that. Huh? That was cool? Okay. How many of you guys are going to remember to do that? Yeah, you might want to write it down. Should we do it again? Should I do it again? I'm going to do it again. So I hit clear to do it. So you go to your y equals, and then what do you do? Vars. So write down vars if you haven't done that yet. You might want to put this on your 3x5 card. Then you want to go to what? 5 statistics. Then EQ. And then number 1 regression equation. Yeah. And then number 1 regression equation. Okay, hit graph. Let's see how it models the data. We did cubic, right? Is that what you had right there, Ramon? It went back to quadratic? Quadratic looks better? Is this quadratic or is this? That's cubic. I would think that a quadratic might look a little bit better too. I could be wrong. I don't know. That one looks pretty good too, doesn't it? Let's do this. Let's make it a prediction on this one, okay? Because it asks us after number 1A to find that we have to. How many subscribers were there in 1996? If you hit second and calc and hit value, you can put 1996 in there. How many subscribers were there after 1996? About 43.17 million if you use the cubic. You're on the quadratic, right? So it might be a little bit different. This is a good contrast, though. It might be good to look at that. So 43.17 million compared to, what was yours again, Ramon? 44.3 million. So that's pretty close, isn't it? So then we can do this. The next one is to predict model subscribers. So we can go back to the graph, and we've got the, we can hit the trace button. Trace. Now right now it's just tracing the, okay, right now you see this upper corner, when you hit the trace button, it will tell you which function you're tracing. Well, right now we're tracing the stat plot. We want to trace the equation that we put into y equals, right? So if you hit the up button right there, now we're going to trace the other one. So now we're going to trace our equation. Pretty darn close to it, right? About what year would they reach 200 million if they keep following this pattern? 2004, and we went a little bit beyond it. It's 2004.8, so maybe we could say somewhere around 2004.6 or 0.7, right? Well, 0.7, that's about 6.5 months into it, a year, right? Okay, so 2004, probably in the year 2004, somewhere around June or July of 2004, they hit 200 million. Do you think after a while this might level off? Because pretty soon you're going to saturate the Earth's population, right? Okay, you know what? We ought to look. Maybe when you guys are doing an activity here for review, I'll let you guys. I'll look it up and see if I can find it for you. Okay. All right, that's the problem we're going to do. Are there any questions you want to ask about this? Sadie. For A, what do you put? It says, write a model that relates the millions of subscribers as a function of the number of years since 1990. That would be this equation under y equals. Except for I would just round it to three or four decimal places each variable. So the first one I'd write negative 0.03299 x cubed plus 198.3935. Okay? Set my phone over there, ringing. Okay. So we got that. So you just have to round it to four decimal places and write your equation. A model, you guys, a mathematical model is usually an equation. Got that? So you're going to hear that term a lot during your math career, because a lot of you guys are going to have a math career. Maybe some of you won't, but some of you will. Okay, you guys all know, did I tell you already we're having the test next time, right? Today we're reviewing. Okay. So, we got that? All right. How many of you finished this assignment right here? Parker's the only one. Sean, you got it done? One more problem? Okay, I know they're kind of long tedious problems. You have to have the calculator. I will give you time at the end of class to do one. How's that sound? Okay, I'm going to do a short review right now. Okay, I want everybody to grab markers and boards. Markers and boards. Go grab them. Okay, we're going to play numbered heads. Everybody know the group they're in? All right. Well, you guys only got 2 people in your group today, don't you? You guys handle that? Maddie and McKay? Maddie, you're 1 and 2. McKay, you're... Okay? All right. Okay, first question. F of x equals negative 6x squared plus 4x cubed minus 8x to the 4th plus 9. State the and the leading coefficient of that function. When you have it, check with everybody else in your group, and then we'll spin. Okay, spinning. Person 4 if you have 4 people, person 3 if you have 3 people. Raise your board. Okay, 1, 2, 3, 4, like that. That's correct. Correct. That's so small, McKay, draw them bigger when you're back there. Okay. Okay. Good. Good. Okay. Degree 4. A leading coefficient of 8, right? That's the give me problem on the test tomorrow. Can you guys do that one on Tuesday? Okay. Next problem. I want to know, you guys, is x plus 2 a factor of that polynomial? Is x plus 2 a factor of that polynomial? Hey, you talk about the difference between a factor x plus 2 and a solution or root x equals negative 2. Okay, if I give it to you as a binomial factor, to find the solution of that, you would want to know what number can I put in for x, add it to 2, and get 0. What number would that be? Negative 2, because negative 2 plus 2 is 0. So negative 2 is the number I'm going to divide into it. If I write it like this, if I give it to you, x equals negative 2, I'm giving you the root. You don't need to change the sign. Does that make sense? Okay, so in this case, x is negative 2. So if you're, how many of you did it by synthetic division? How many of you did it this way? Okay, if you did it this way, my coefficients are 1, then what? 0. That's right, because we're missing the x cubed term. Then 6, then 0, because we're missing the x term, and then 8. And then you go like this. Bring down the 1. Negative 2 times 1 is negative 2. Add, you get negative 2. Negative 2 times negative 2 is 4. Add, you get 10. Negative 2 times 10 is negative 20. Add, you get negative 20. And negative 2 times negative 20 is 40. Add, you get 48. So my remainder is 48. For it to be a factor, what does my remainder have to be? 0. Remember that on the test. Did you guys know that there's a faster way to do this? Using the remainder theorem. All you have to do is take the root, which is negative 2, and do f of negative 2. Negative 2 to the 4th plus 6 times negative 2 squared plus 8. Well, if you go negative 2 to the 4th, that's 16. Negative 2 squared is 4. Negative 2 to the 4th power is negative 2 times negative 2 times negative 2 times negative 2, which is 16. Put in your... Okay. No. Negative 2 squared is 4. 4 times 6 is 24 plus 8 would make 48. Notice we got the same number as we got when we divided, because that's the remainder. Okay? So you can do it either one of these two ways to get your answer. You need to show your work on the test. Got it? You either need to show synthetic division, and you need to say, okay, the remainder is 48, so no, x plus 2 is not a factor. Okay, Easton. Well, you could, but we're not looking for that. All we want to know is what the remainder is. It's 48. It's not 0, so it's not a factor. Does that make sense? Okay, so that's what you have to do on that one. You would write no, but you have to give credit. Does everybody understand this? I would write a reason. I would say, well, the remainder's not 0. It's 48. Therefore, it's not a factor. Well, writing it out in synthetic division will tell me what the remainder is, but it doesn't tell me whether you understand whether this is a factor or not. So you have to say no because the remainder is not 0. Do you understand that, Rachel? Any other questions? You need to be able to explain why. Okay, the next one. Okay, I want you to solve this equation by factoring or using the quadratic formula. Solve that equation by factoring or by using the quadratic formula. Okay, so we're going to use the quadratic formula. To solve this quadratic equation. We know that A is 5, B is -6, and C is 2, right? So we're going to plug these in here. The opposite of B is a +6. -6 squared is a +36. -4 times 5 times 2, all over 2 times 5, which is 10. Okay, if I simplify that, 4 times 5 is 20, 2 times 20 is 40, so 36 minus 40 is -4. And we know that the square root of -4 is what, you guys? 2i, because the square root of a -1 is I, and the square root of 4 is 2, so it's 2i. So we get 6 plus or minus 2i all over 10. Now, you guys, the top number, a 2 will factor out of it, right? And that will leave us a 3 plus or minus I all over 10. And then 10 factors into 2 and 5, and so the 2's would cancel out, right? So my answer would be 3 plus or minus I all over 5. Okay? Most of you had that. That was a good job. I was impressed. Okay? Guys, remember this video, if you need to go back and watch it again, I'll post it. So, I mean, it's a long time between now and Tuesday when we're taking the test. So you might want to look at it, you know, Monday or Tuesday. Monday, so you can be ready for it, okay? Any questions on this one? Yeah. Well, I was just showing them that, I mean, another way to do this is 2 will go into 6, 2, and 10. So if you divide 2 into all of them, that's 3, that's I, 1i, and that's 5. But what I did is I factored a 2 out of the top. If you factor a 2 out of the top, when you factor 2 out of 6, that leaves 3, and a 2 out of 2i leaves I. And then I canceled that 2 on the top with a 2 on the bottom, because 10 is 2 times 5. Got it? Okay, next problem. I'm going to have to pause this for a second and come up with a problem, because it's not easy for me to come up with one. Okay, given 1, 0 is -4, find all the zeros of p of x equals x cubed plus x squared minus 22x minus 40. Guys, I want you to don't do this calculator, because I don't know if the other two solutions are real or imaginary, but I think on the test, the one I give you is real, obviously, and the other two are imaginary. So I want you to do it using synthetic division. Divide -4 in there. Reduce it to a quadratic equation, and then solve the quadratic equation. Okay. All right. Show me your answers, you guys. Everybody. I want to see everybody's answers. Okay. Okay. Some of you guys have +5 and -2, and some of you have negative and positive. Let's work it out. Okay, I wanted you to do this one using synthetic division. So I'm going to put -4 here, and I have my coefficients of 1, 1, -22, and 40. And I go negative 4 times 1 is negative 4. Add, I get negative 3. And negative 4 times negative 3 is 12. Add to get negative 10. And negative 4 times negative 10, add to get, is 40. Add to get 0. So that one worked. I have my quadratic x squared minus 3x minus 10 equals 0. If I factor that, I'm looking for the two numbers that I can times together and get negative 10. And so when I add them together, I get negative 3. X minus 5 and x plus 2 are the two factors that give me that number, right? And if I set each factor equal to 0 and solve, I get x equals a positive 5 and x equals a negative 2. So those are my other two zeros. So now, you guys, if it doesn't work out that this is not factorable, what do? Use the quadratic formula. Got it? Okay, the next one. I want you guys to find all the real zeros of this next one. If I say find all the real zeros, all you have to do is use a calculator, find out where it crosses the x-axis. You know, even though it looks like it might go through an integer, it's good to use that zeros function underneath the calc menu, just to double check to make sure it's not 3.9. Okay? Because I want you to round it to the nearest hundredth. Okay, show me what you have. You guys should have been able to get this one. Just looks like you all have the same answers that are holding up your boards. What are they? Negative 4, positive 2, and positive 1? Negative 4, negative 1, and positive 2? Okay. So it's negative 4 and negative 1, you guys, then positive 2. Okay? All right, the last one we're going to do is finding the complex zeros of a function. So given f of x equals x to the 4th plus 8x squared minus 9, I want you guys to find the complex zeros. Find the complex zeros. Give you a hint, you guys. To find all the complex zeros, first of all, well, actually, first thing you need to determine is how many complex zeros are there? Why 4, Jerica? Because it's degree 4, right? Whatever the degree is, that is how many there are. So, Bryce, this one has how many zeros? Complex zeros? Well, Bryce, how many complex zeros does this have? Why? Okay, how many complex zeros? This is an easy question. Think about it. What? Oh, okay. That's because he was working on something else last time I told you that. Okay. Bryce, how many zero? Okay, why? That's right. Okay. So the first step is to determine how many zeros it has, and it's 4th degree, so it has 4 zeros, right? And the next step is to determine how many real zeros there are, right? So how do you do that? How do you determine how many real zeros it has? And what? You graph it, and then you can find out what they are, right? What happens after you find the real zeros? You divide it into it using synthetic division to reduce it down to a quadratic function. And then you use the quadratic formula or factoring to solve it to get your imaginary zeros. Okay, we're going to do this one. Like I said, you first of all determine the degree and how many complex zeros there are. Well, the degree is 4, and that means there's 4 complex zeros. First, and then we're going to find the real zeros before we find the complex or the imaginary zeros. So we put it in our calculator. You guys found out that the real zeros were 1 and negative 1. Is that right? Okay, by putting in your calculator and seeing where it crossed the x-axis. It crosses the x-axis at 1 and -1. Okay, then you use synthetic division to reduce it down to a quadratic. So I'm going to take 1 or -1. It doesn't matter which one you divide into at first. You just take them both. And my coefficients are 1, 0, 8, 0, and -9. Don't forget about your zeros. Bring down the first one. 1 times 1 is 1. Add, get 1. 1 times 1 is 1. Add, you get 9. 1 times 9 is 9. Add, you get 9. And 1 times 9 is 9. You add, you get 0. Remember, if you don't get a 0 on that last one, you know you did something wrong. Okay? Then I can just use those same numbers again. Someone was asking me about that. And I can now divide -1 in there. -1 times 1 is -1. Add, you get 0. -1 times 0 is 0. You add, you get 9. -1 times 9 is -9. You add, you get 0. So once again, I know that those two are both zeros because the remainders are zeros. Then I have my quadratic function. 1 is the coefficient for x squared. 0 is the coefficient for x. That makes it kind of nice when the middle term is 0. Plus 9 is my constant equals 0. Since I'm missing the middle term, I need to use the quadratic formula. All I have to do is -9 from both sides. And then take the square root of both sides, right? So x equals plus or minus 3i. Remember, whenever you take the square root of both sides, it's plus and minus. And so I get a positive 3i and a negative 3i. 3i are my other two answers. So I want you guys on the test to list them all together and circle them so I can see them. Don't leave them all over the page. It makes it hard for me to find them and correct them. Okay, so put all of them up there like that. Any questions? All right, I'm going to tell you. Also on the test will be a problem like we did at the very first of class, putting those stats in the computer or in the calculator and finding the model that best fits the data. And I think on the test I made it pretty obvious which one will fit it. But look at your data and see which one is, whether it's quadratic, cubic, or linear. And put that data in there and know how to calculate those. If you guys want, for the next time we come to class, I'll go over maybe 2 or 3 problems. Probably the 2 hardest problems was one like this, finding the complex zeros, and then doing the data questions, okay? Do you guys all know how to do synthetic division? Do you know, what do you do if you're doing synthetic division and you get a number other than 0 right there? Do you know? Well, you can put r, the remainder, or you can put plus the remainder over the divisor. So let's say you got 22 as your remainder. You'd put 22 over, and let's say your divisor was x plus 4. So you'd put plus 22 over x plus 4. And that's your polynomial equation, okay? You can put remainder 22. Okay? But that's basically what we did today is the test, plus that data problem, okay? Jerica. I'm going to say this again so in case you guys watch it over. So if you're doing synthetic division and you come up a remainder of 10 like we did right here, when you rewrite your new polynomial, you can call it anything you want, r of x. It's equal to 1x squared, because remember you reduced it from a third degree polynomial to a second degree polynomial by dividing one number into it. Minus 3 plus your remainder, which is 10, over the divisor, which was x plus 2. Got it?